Hello everyone, welcome to Code with Laya. Today I'm going to explain you a new topic called as binary search. So what is this binary search? What is binary 2? Okay, remember this. And it is the more efficient searching algorithm than linear search. So what you are doing in linear search, in case if you want to search an element, okay, you keep on comparing the search element with each and every element, right, till the last element. In case if the element is not found with the last element also, your time is getting wasted, memory is getting wasted, and also your energy is not being utilized properly, right? So even if say for example my element is I have 100 elements to be in the array, so I want to search an element and I've done almost 98th comparison. There also I did not found my element. I found my element at 99th position. Okay, I found my element at 99th position, right? So for this 99th position, what am I being doing? So I keep on searching from 0 to 98. Almost 99 comparisons are being made. So I found my element at last. So that's the worst case you can find the element, right? If the element is found at the beginning itself, then it would be the worst case. But what if the element is found at last position? So much of time is being wasted, right? To overcome that problem, we have come to the binary search concept, right? So what is happening in binary search? It is used to find an element in the sorted array, right? In the linear search, you did not have any rule that your elements should be arranged in either sorted order or unsorted order. You have took random elements. I took 16, 43, 1, different order, right? But here, the element should be in either ascending order or descending order, right? So, it works by dividing the array into two halves, right? What is meant by binary? Two halves, right? Now, we'll see the working of the binary search, okay? A small example, let us suppose an array of 4 elements. My elements are 11, 15, 19, 23. I said it should be arranged in either ascending order or descending order. So I've arranged them in ascending order. Okay. So first what will I do to make it two halves? I have to calculate the mid. So what is mid? This is lowest index. This is highest index. So what is the formula for calculating the mid? Low index plus high index by 2. What is my low index? 0 plus what is my high index? 3 by 2. What is 3 by 2? 1.5. I will only consider the integer floor value, right? So this is my mid. Okay. So there is a condition. You want to search an element. The element can be found at particularly at mid element, mid position. Okay, my element, for suppose my search element is 15. It might be found at mid only. There is an option, right? My mid element might be my search element, or my search element is some, for example, 10. So 10 is less than 15. So I have to search in the left side of 15. Right? I need not go to the right side. If I already know that the elements less than 15 are placed at its left side, so why will I check? Okay, why will I check my right side elements? Right? So here I'm not wasting my memory, or I'm not wasting my time for searching that element. Right? So for suppose my search element is 45. So will I search to left side or right side? Obviously, I'll search to right side because all the elements greater than 15 are placed to right side. Will I search left side? That's of a time waste, right? So this is how the binary search is performed. Now I'll explain how this binary search is being performed. So this is my mid element. So there would be 3 cases. My cases are if A of mid equals to search. So I have to compare the search element with mid element first. So first I have to see if my search element is 23. If search element equals to A of mid. Is it okay? So if my search element equals to mid, what should I do? Printf element found. I can directly print it. Right? If my search element is less than my mid. Okay? If search element is less than A of mid, that means it should be around this way. So, will I search these elements? I won't search. So, I will consider only these elements. Right? Now, what happens in case if search element, my search element is 23 is less than 15. Is my 23 less than 15? No. So, I'm not going to search in the left side again. So, another condition is if search element is greater than A of mid. This is my search element 23. Is 23 greater than mid? Is 23 greater than 15? Yes. 23 is greater than 15. So I need not check my left subarray. Okay. So I need not check to the left part. So what will I do? I will leave this part and what I'll do is high is left as it is. But low value, if I consider again this only, I have to check this also. This time I don't want that, right? Now what I'll do is I'll take this as low value. Okay. So for taking this as low value, what should I do? My low value equals to mid plus 1. Okay. So in case if I want to go and search in the right subarray, okay, in case if the my search element is greater than my, in case if my search element is greater than the mid element, what will I do? I will go to the right side. So for going to the right side, I've considered this array. This will become my low element. So for this to become low element, what should I do? I have to add 1 to the mid. Then it became low. Right? So now my low value is equal to, what is my mid right now? 1. So 1 plus 1 equals to 2. So this is my array I have to search now. That 2 and 3. Index should not changes. You will get wrongs. So mid equals to 2 plus 3 by 2. Okay. So 5 by 2, that is 2.5. You consider only 2. Right. So this is my mid value. Okay. Now what you'll see, this condition. If search equals to mid, what is my search element? 23. Is 23 equals to mid value. What is my mid right now? A of 2 is the mid. That is 19. Is 23 equal to 19? No. Here condition is not being satisfied. After this I went to this statement. Now 23 is my search element. Is 23 less than my mid element? Again no. Okay. Now after this, if 23 is greater than A of mid element, what is my mid element? 19. Yes, it is greater than mid element. So what I'll do? What did I tell you? Low equals to mid plus 1. So what is low right now? This one. Okay. This is my low. So low. So here you found that there is no, my element is not found at mid position. So you need not check it. But that is only the low element, right? So now you have to go to the next position. Now low equals to, what is my mid right now? 2. 2 plus 1 is my low. Okay. So there is only one element, 23. Low is, 3 and high is 3 and mid is 3. How did you get that mid is 3? So what is my low index? 3 and what is my high index? 3 by 2. What is 6 by 2? 3. So my mid is 3. Okay. So now I'll search. Is 23 equal to A of 3? That is 23. Yes, element is found. Okay. So this is how You implement the binary search working.